The nice thing about this particular problem is you're given the primary equation. This couldn't be any easier. The profit in thousands of dollars for a company spending an amount of S in thousands of dollars on advertising is P equals negative 1/10 S cubed plus 6S squared plus 400. Find the amount of money the company should spend on advertising in order to yield a maximum profit. So we're just looking, this is just like curve sketching. We're just looking for the maximum here. Here's our primary equation. We already got it. Sometimes you're given the primary equation, not too often. But it's P equals negative 1/10 S cubed plus 6S squared plus 400. So now take the derivative. This is going to be a fast one. And find the critical point. Or points. But usually point. You may get more than one answer, but usually that answer is not in the feasible domain. And so here, what's our feasible domain? Could you have a negative profit? Well, yes, you could lose money, but since we want a maximum profit, let's assume that profit should probably be greater than 0, or you haven't made any profit at all, right? And they're spending money, right? So if there's so S here stands for spending money. So if they're spending money, that's going to be a positive. So S is going to be greater than 0. All right, so we've got dp ds equals, right? So derivative of negative 1/10 S cubed would be negative 3/10 S squared. Derivative of 6S squared would be 12S, and the derivative of 400 is 0. So we're going to set that equal to 0. 0 equals negative 3/10 S squared plus 12S. Let's multiply everybody by 10 and get rid of that, the 10 in the denominator there. Right? So if we multiply by 10, we have 0 equals negative 3S squared plus 120S. Let's factor out let's take out the negative. So let's factor out a negative 3S. So that would be S, and that would be a minus, and that would be 40. So either S equals 0, they don't spend anything, or S equals 40. And be careful, it's not $40, it's $40,000. Let's do first and second derivative test. All right, let's check, make sure this is actually a maximum. All right, so we've got 40, and this one is not in the feasible domain. All right, so we have 40, and then we'll use 1, and I guess 41. So if I plug a 1 into the, actually let's do 50 instead of 40. That'll be easier to plug in. If we plug in a 1, we're going to have a positive number. Right? We're going to have 12 minus 3/10. So whatever that is positive. If I plug in 50, right, I'm going to have 12 times 50 would give us 600. And then 50 squared is 2,500. So let's see, we have 2,500 times 3. So that's going to be negative 750 and positive 600. That's going to be a negative number. Right? So since f prime of x changes from positive to negative at x equals 40. X equals 40 is a relative maximum. Right, and then let's do the second derivative test. All right, so we have f double prime. Oh, instead of writing it like that, I'll use the letters we've got. D2p, oops, D2P and DS2. All right, and so we got negative 3/10 s squared. That's going to be negative 3/5 s, and then plus 12. So we're going to plug in the 40. So D2P DS2 at 40 would be, because that's our critical point, negative 3/5. Does it truly work out that this is going to be a positive number? Then we know for sure it's a relative max. I mean a negative number. Then we know for sure it's a relative max. All right, and so this would be 40 plus 12, and this is going to be negative 24 plus 12, or negative 12. So since f double prime of 40 is less than 0, x equals 40 is a relative max. Our function here is concave down. All right, so let's answer the question that we were asked to find. All right, so the company. So do make sure you answer the question that you're asked for. All right, so you got all the solving here, but take one moment to answer the question, and don't make someone look for your answer. All right, so the company should spend $40,000 on advertising to maximize profit. So that's a nice, easy one. And there we go, done. 7 minutes. All right, thanks for watching. Bye for now.